In today's lesson, we are going to look at applying slope, midpoint, and length formulas. So not really anything new in terms of actual calculations, but we're just going to be using them to verify different properties or to prove certain things, looking at some of the geometry concepts that we've kind of talked about before. So we're not going to learn any new formulas or anything like that. We're going to be using the same ones we've looked at in the previous lessons and just apply them to help us verify some properties. So first thing, the shortest distance between 2 points on a flat area or on a flat surface is a straight line. Now in some cases that may not be the case, but usually a straight line is the shortest distance. If we're dealing with something that's not flat like the earth, so to speak, then a curved line might be more appropriate and not just a straight line. But for our purposes, the shortest distance will be a straight line, and generally it will meet at 90 degrees. Right? So generally it will meet at 90 degrees. We'll say usually. Not all the time, but usually it'll be 90-degree angle. And if two lines are perpendicular to each other or meet at 90 degrees, they have slopes that are, we talked about this before, negative reciprocals. So if they're the negative reciprocal, an example might be, let's say we have a slope of 1/8. Then the perpendicular slope would be, we flip it and make it the opposite sign. So 8/1 or -8 or -8/1. So those are some of the properties we want to keep in mind, right? Some things to kind of have in the back of our head when we're talking about perpendicular or the shortest distance, depending on what our question or scenario has. First question though says the vertices of triangle A, B, and C are A 5, 5, B -3, 1, and C 1, -3. Determine whether a triangle A, B, and C is a right triangle. And so there are two ways that we could do this. There are two ways that we could check. Right? The first one, easy one, if it's a right angle, we should be looking for slopes that meet at 90 degrees. So slopes of two lines are perpendicular. Right, so that's that idea of that negative reciprocal. Right, so slope of two lines are perpendicular, or you might say negative reciprocals. The other scenario that we could check, if we're dealing with a right angled triangle, the other thing we could look for is we could check or prove the sum of squares. Sum of squares or Pythagorean theorem, which says that if we square one side and add it to the square of the other, it's going to equal the square of the length or the hypotenuse. Right, so I could use either one. I could check the slopes for two lines and see if they're perpendicular, or I could prove the sum of squares formula. So the sum of squares would require me to find the lengths of every side and then plug them into this calculation. So the method we're going to use in this example is we're going to use number one. We're going to find the slopes, or we're basically looking for slopes are negative reciprocals. And this one is easier because based off of my drawing, I can probably guess which two sides of the triangle I'm going to look at. And I'm going to be looking at these two here. Assuming that it's been graphed properly, I'm checking, is this angle 90 degrees? That's what I'm looking for, right? Just by looking at the visual of it, I can probably guess it's not going to be either of those two angles, right? Because those ones clearly don't look 90 degrees. So I'm going to check for this angle down here. So in order to do that, I need to find, keep the colors consistent, I need to find the slope of BC, and I'm going to need to find the slope of AC. Now, two different ways we could do it. I'll go through both methods. One method is we create a table of values using the 2 points or the values from the 2 points that we're choosing, or the endpoints of our line segment. So we have -3, -1, and we have 1, -3. Here I can check the change in y and change in x. Move this down. So y changes by, we go down 2. X changes by, we go up 4. So this means with a change of y divided by a change in x, our slope for BC is -2/4 or -1/2. For the other line segment, AC, I'll use the algebraic formula. So again, remember the algebraic formula is y2 minus y1 divided by x2 minus x1. So I can take those values and plug them in to our formula. Right, y2, we'll say, is 5 minus -3 divided by 5 minus 1. We get 8/4, or we get 2. AC. So looking at these two slopes, are they perpendicular? Right, so because these two slopes are perpendicular, so they are negative reciprocals, right? They're opposite and they're flipped. Therefore, BC is perpendicular with AC. So it is a right triangle. So a right triangle, right, needs to have that 90-degree angle. So this angle is now 90 degrees. We have proven that by looking at the two slopes. So we can verify, or we verified, that this is a right angle triangle. Next example, right, looking at some properties, we want to show that the median from the right angle of the triangle in triangle ABC is half as long as the hypotenuse. Now we found which angle is the vertex, or which vertex is the right angle in our previous question. Right, looking at this diagram as well, if we're told that there's a right angle, we can probably guess which one it is. Our right angle is down here. So we are looking to see is the median, which runs from this vertex here to the midpoint of the other line that I'm just going to put arbitrarily. Looks like it might be there. Just make a nice line connecting them. Doesn't always have to be a straight vertical line. I'm just guessing where it could be. So this is our median. This would be our midpoint. I want to basically verify that this median is half the length of this side, or the hypotenuse, going from here to here. So because I'm trying to find the length, I'm going to need to use my length of a line segment formula. Now before I do that, I could go through and find this midpoint. Right, so the midpoint of AB, we'll find that first, and then we'll go through and we'll look at our length of a line segment. So our midpoint, we take, we have two values. We have the midpoint for x. So we have x1 plus x2 divided by 2. We have y1 plus y2 divided by 2, or x2 plus x1, whichever order is fine for this, because we're adding. So we have 5 plus -3 divided by 2, and 5 plus -1 divided by 2. So we then get 2/2 and 4/2, or 1 and 2. So that's pretty close actually with where I guessed the midpoint to be. We can just make it a little bit more accurate now, because I do know where the midpoint is. It's going to be directly up. And so again, I am looking for now the length of the hypotenuse and the length of the median. So we'll start with the median. Again, this one's also pretty easy because it's almost vertical, or it is vertical. So median, we'll call this CM. So the length of the median, or CM, is the square root of x2 minus x1 squared plus y2 minus y1 squared, all under the square root. So I get x2, we'll have our point here of 1, 2. So we have 1 minus 1 squared plus 2 minus negative 3 squared, all under the square root. 1 minus 1 is 0, 0 squared plus 5 squared. 0 squared is nothing, 5 squared is 25. Oops. So the square root of 25 is 5. So that is the length of my median. So let's put it down here so we can compare them side by side. So this is our median, CM. Now we're going to do the hypotenuse, which is AB. So the length of AB, exact same formula, x2 minus x1 squared plus y2 minus y1 squared. x2 we can say is 5. So 5 minus negative 3 squared plus 5 minus negative 1 squared. Square root of 8 squared plus 6 squared, or the square root of 64 plus 36, the square root of 100, which is 10. So therefore, comparing the two, the median is half the length of the hypotenuse. And so again, we were told that this was the case. We just needed to prove it. We needed to prove that the median from the right angle to the midpoint of the hypotenuse is half its length. So again, we were told that from the beginning. We just needed to go through and do the calculations to prove it, to prove that that is the case. That is a property of right angle triangles. And so again, none of the formulas we used were any different from the previous lessons. There's nothing new to these formulas. The main thing is we're just now using those formulas to verify some geometric properties. So just make sure we understand how to use length of a line segment, midpoint, looking for right angles using slope, and all of those things to help us verify these properties.